Hello, I will go through the entrance exam Mass B of July 25th, 2023. Question 1 is about rational functions. There's a function f given here. Points A and B are points on the graph where the tangent line to this graph is horizontal. Point C is the intersection of f and the y-axis. Line L is a straight line through A and B, and M is the tangent line to f at point C. And what they want to know, the angle between line L and line M. And give your answer in degrees, rounded to 1 digit behind the decimal point. Okay, so we have two lines L and M, and we need to know the angle between them. So for this, in this case, we can use what's in the syllabus mentioned under straight lines and angles, and we find the two direction angles of the line. So the direction angle. So we need to know the coordinates of point A and B. And for point C, we just figure out what the derivative is when it intersects with the y-axis. So that will be at x equal to 0. Okay. So let's figure out point A and B. The tangent is horizontal. That means that the derivative of f in point A and B has to be horizontal. So we need to figure out where f prime of x is equal to 0. So what is f prime of x? Well, we use the rule that we know for taking the derivative of a ratio of functions, a quotient of functions. So that is f prime x equals the denominator times the derivative of the numerator, which is 2x plus 4, then minus the derivative of the denominator, which is just 1, times the numerator. Okay, and then this whole thing divided by the denominator squared. And we have to set this equal to 0. That will tell us what the x coordinates of A and B are. So let's simplify this. We get the derivative of f is, well, let's combine so-called like terms. So first, the terms with x squared. We get 2x squared here and a minus x squared from here. So you get an x squared. Now let's look at the x's. So you get 4x plus 8x is 12x. And here we get a minus 4x, so we get overall an 8x. And the constant term is 16 here, minus 4 is 12. And again, divided by that same denominator. So this is 0. Well, that simply means that x squared plus 8x plus 12 has to be equal to 0. Thus, we need to be careful that x cannot be equal to minus 4. then this will be singular. Okay, so that means that, let's see if we can factorize this. Look at all the factors of 12. So 1 and 12, 2 and 6. Well, there you go, 2 and 6. If I add 2 and 6, I get 8. So this is simply x plus 2 times x plus 6 is equal to 0. And x not equal to minus 4. So this means x equals minus 2 or x equals minus 6. And in both cases, x is not equal to minus 4, so these are valid solutions. So now we can just say, okay, A, we can just pick minus this one for A and this one for B. Doesn't matter if you do it otherwise. You can also pick minus 6 for A. Should get the same results. So you get minus 2. And then, well, what is the y coordinate of A? Let's just let's do that here. Y A is simply f evaluated at minus 2. That is minus 2 squared is 4, and minus 8 plus 4 divided by x plus 4, which is minus 2 plus 4 is 2. Well, you get 0. And let's also do yb. That will be f evaluated at minus 6, 36, minus 24 plus 4 divided by minus 2. So that's 12 is 16, 16 divided by minus 2 is minus 8. So our A is minus 2, 0, and our B is minus 6, minus 8. So now I have A and B, and if I know 2 points on the line, I can easily find the slope of line L. So having the slope is enough, as I just mentioned. The slope will give you the direction angle. And so that will be, well, let me write it out, yb minus ya divided by xb minus xa. You can also say ya minus yb and xa minus xb. You'll get the same result. So that is negative 8 divided by minus 6 minus negative 2. So plus 2. So it's minus 8 divided by minus 4 is 2. So that's the slope of line L. Then for line M, the slope is just the derivative of f at the y-axis, or where it intersects the y-axis. So it's the derivative of f of 0. And then I just substitute 0 in the expression for the derivative here. So you get 12 divided by, and this is x plus 4 squared, is 16, which is 3 divided by 4 is 0.75. Well, no, let me just keep it like 3. Well, actually, it's okay. Never mind. Either way is fine because we have to plug it in a calculator anyway. Okay, so this means the direction angle is, uh, let's call it the alpha L is the inverse tangent of 2. And here alpha m is the inverse tangent of 0.75. And let's find our calculator. 2, and let's find the inverse tangent. Sorry, wait, I have to put it in degrees. Sorry. 2 inverse tangent is 63, and let's just keep 2 decimals for now. And let's do the same for 0.75. That is 36.87. So now we can just subtract them, one from the other. And again, note you have to put it in between 0 and 90 degrees, as mentioned there. So if you find something that is not within that, you need to take either the complement or just change the sign. So you get then the angle L and M equals 36.43 minus 36.87. Okay, I have this. Okay, let's just 30. It's 26.56. And that is then up to 1 decimal, 26. Here, here also made a mistake. 26.56, 26.6 degrees. So that's the answer of 1A. Okay, in 1B here, they give a function g, and they want to know for which values of p the horizontal line y is p has 2 intersection points with the graph of g. So what are the intersection points? Well, g of x equals to g. or 1 over this thing here is equal to P. So let's just do the cross calculation, right? If uh, A divided by B equals C divided by D, that is equivalent to AD is BC, provided that B is not equal to 0 and D not equal to 0. This is actually also some basic math even mentioned in the syllabus. So what we find then, and of course the denominator here is just simply 1. So you can, let me see, you get 1 equals P times that thing. And make sure no mistakes. And what I can do is bring the 1 to the right and expand the parentheses. So get px squared plus px and get a minus 2p here and a minus 1. This has to be 0. So this equation determines your axis, your x, for where there is an intersection with this horizontal line. Now they say this equation needs to have 2 intersection points. So here you need to apply your knowledge about these kind of quadratic equations and how many solutions they have. And this is also in the syllabus. The number of solutions is determined by the discriminant, which is given by p squared, which is p squared minus 4 times a, the coefficient in front of x squared, times the constant term here. And this has to be greater than 0 for it to have 2 solutions. So that means that p squared, and let's work this out. Here you get negative minus 4p times minus 2p, so you get plus 8p squared. And here you get a minus 4p times minus 1 plus 4p. So that is 9p squared plus 4p greater than 0. We can pull out p to get p times 9p plus 4 has to be greater than 0. And by writing it in this way, and this is again a quadratic function in p, and we have to figure out where, for which p this is greater than 0. So we can just write a number line and look at the 0 points. So one is 0, and the other is a minus 4 over 9. So we can just figure out, so if p is very large, then this obviously is greater than 0. So you can say these are pluses, and then actually I don't even need to fill in a number. This has to be negative then, and this has to be positive. And at this point, it's exactly 0. So we want to be in the interval, so that p a belongs to minus infinity to minus 4/9, or from 0 and not including. So these triangle brackets indicate that it's not including 0 and then to infinity. So for these values of p, this function has two solutions. Is that what I asked? Okay. Now 1c. The graph of h has two asymptotes. Compute exactly the equations of these two asymptotes. All right, so we have this function here. Let's just see if we can rewrite this in some way. So x squared minus 4, some of these forms you need to be able to immediately see that you can write this as x plus 2 times x minus 2. The cross term will vanish. And so times x plus 1. Let's see about the denominator. Well, look at all the factors of 2, 1 and 2, minus 1, minus 2. So you get x minus 1 times x minus 2. So this is equal to x plus 2 times x plus 1 divided by x minus 1, provided that x is not equal to 2. So x equal to 2 is not in the domain of this function, because the denominator will be 0. So this one has two asymptotes. Now, what actually, so let's look at possible vertical asymptotes. So from this, you can see that it has a vertical asymptote when x equals to 1. So the vertical line x equal to 1, because you can see if I substitute x equal to 1, I get something non-zero divided by 0. So that will form a vertical asymptote. Now, what happens when x reaches 2, actually? You can also wonder. Well, when x is getting close to 2, note it cannot be 2 exactly, but if it reaches 2, if you approach 2, then you get actually a finite number. Right? Substitute 2 in this one, you get a finite number. So actually at x is 2, it is a, how do you call it, a perforation. So yeah, so there's only one vertical asymptote, x equal to 1. So then it must have a horizontal asymptote. So we need to look at the limit of this thing going to infinity. So what you do in these kind of situations is to do a so-called long division. So we write it back to, so let's see, so hx is x plus 2, x plus 1 divided by x minus 1 is x squared 2x plus 3x plus 2. So we get x minus 1, x squared plus 3x plus 2. So you need to multiply by x, and then you get x squared minus x, and then subtract these, you get 4x, and have this 2 here. So then it's a plus 4. You get 4x minus 4. You need to subtract them. That's 6. So the remainder is 6. So basically you get here, this is x plus 4 plus 6 divided by x minus 1. So in other words, so the limit of this function going to plus or minus infinity is basically the limit of x plus 4 plus 6. So basically the limit of x going to plus or minus infinity of hx minus x plus 4 is 0. The horizontal asymptote is the line y equals x plus 4. So we have this as the vertical asymptote and this as the oblique asymptote. Yeah, here actually I have to put parentheses here. So this function hx approaches the function x plus 4. Question 2a. The function f is given by this, and then there's a circle C that touches the graph of f at the points minus 1, 1 and 1, 1. Compute exactly an equation for the circle C. Okay, that is a little bit of a tricky question. Let's try to find let's try to draw this function. So at x equal to 0, you get e. Let's say this is e. And x equal to 1, you get 1. So this is 1, you're somewhere here. And minus 1, you're somewhere here. And it is symmetric in x. And if x goes to plus or minus infinity, it goes to 0. So it will look something like, it's actually something like a bell curve. This looks a little bit like a normal distribution, although I draw it pretty poorly. Now you could write a circle in it that, uh, yeah, that touches this function in 2 points here. Okay, I drew it very poorly actually, but you get a point. This circle has to touch, and this happens to be a minus 1, 1. So this is actually the points I drew are A and B already. So what does that mean? If they touch, they both intersect. Plus the tangent of function f here is also tangent of that circle. So the tangent, let's write, say this is the tangent of the function in A. And then here, say line M is the tangent of the function in B. These also have to be tangent of the circle. And that means that these lines are perpendicular to the radius. So here, say you have the radius, and here the radius, and then the circle center is here. Let's call that P. So, and then the center of the circle will be the intersection of these two radii. And so how do we find them? Well, this radius has to be a line perpendicular to this tangent of the function. And it has to go through point A. And this radius has to be a function perpendicular to the tangent in B and going through B. Okay, so what we need to know is the slope of L. And then from that we'll find the slope of the radius through A. And we do the same for line M. So M and then radius through B. So let's do that. What is the f prime of x? We can use the chain rule, that is e to the power 1 minus x squared times a minus 2x. So it's minus 2x e to the power 1 minus x squared. Then f prime with minus 1 is then simply 2. So let's call this RA, this line, and this line RB from radius B. So the slope of the line RA equals then minus 1 over 2. And f prime at 1 is negative 2. So the slope of radius B is 1/2. So then we can find the whole expression for the line RA. We set it say y is minus 1/2 x plus b, but b is then follows by demanding that a is on the line. So b is then y plus 1/2 x, right? So y of a is 1 plus 1/2 times minus 1 equals 1/2. So this line is y equal to minus 1/2 x plus 1/2. Now for b, so we found y is 1/2 x plus b. So b is y minus 1/2 x is 1 minus 1/2 times 1 is also 1/2. So they actually intersect the y-axis in the same point. So actually that means actually that is the intersection. So you can immediately tell that the circle center has to be 0, 1/2. Oh, they have the same y-intercept. So the center P is actually 0 and 1/2. Well, if you didn't see that immediately, you just do kind of the intersection of these two lines. This line here and the second line B. So yeah, I didn't write down. So the expression of RB is plus 1/2 x, also plus 1/2. So the intersection has to be at x equal to 0. So this then is the center of the circle. And now what we need to give the complete equation. So we also need to find the radius of the circle. But that's just the distance from P to, say, A. For which we can just use Pythagoras then. So that is the 0 minus 1 squared plus 1/2 what's point A? Minus 1 0 minus -1. So you get 0 plus 1 squared and then the square root. So this is 1 squared plus a quarter, the square root is the square root of 5/4. So the circle C has the expression x minus 0. So I just can write it as x squared plus y minus 1/2 squared equals, and then the square of this radius, 5/4. There's a function g here and a region V enclosed by the curve of g, the x-axis, and the vertical line x equals e. Compute the volume of the solid of revolution that is formed by rotating V around the y-axis. So let me try to draw this. Y-x-axis, this is x equals to e. Then we have some function that goes something like this, and a area V. Now we're going to rotate this around the y-axis, but only region V here. So what you get is kind of a donut. So you get some solid with an empty center. Now let's first look at what do you get if you just rotate a function g when it is rotated around the y-axis. So that would give you this complete solid of revolution. Let's call this W. W would be the integral. So we start from 0. Don't forget the pi here. From 0 and 2, actually 2 where? What is this point here? That is where g intersects with x, with the vertical line x equals to e. So let's call this a. So what is g? Basically, we need to know. So a is g of e, which is 4 minus 2 times log of e. Well, the log of e is 1, so that is 2. So a here is 2. So the upper limit of the integral will be 2. And then we need to have the inverse function squared. So let's call that x squared. But x is this case, a function of y. And then you integrate over all the y's. And this is the form that is in the leerstof somewhere. Where is it now? Well, I cannot find it that quickly, but again, it's super critical that you go through this leerstof, through this syllabus, and basically every topic. These exams are pretty consistent this way. Okay, here it is. So pi here and x squared, and the x is a function of y that we have to find from from taking the inverse? Well, we know that y equals 4 minus 2 log x. In other words, log x squared. I take the 2 within the logarithm, bring it to the left, and bring y to the right. So we're getting closer. That means x squared is e to the power 4 minus y. And now we substitute it here. And we get w is pi times integral of 0 to 2 of e to the power 4 minus y dy. Well, the primitive here is pretty simple. So you get pi 10 times from the chain rule. You pick up another minus sign. So you get, I just put it in front of the pi, that minus pi e to the power 4 minus y, and between 2 and 0. So that is minus pi times e to the power e squared minus then negative pi times e to the power 4, which is let me put this on front, pi times e to the power 4 minus pi times e to the power 2. That is our w. And as I mentioned, we need to subtract this center of this donut-like shape. And that is, you can you can basically do the integral if you want, because x is e. So it's basically the integral from 0 to 2, or don't forget the pi, of e squared dy, which is simply 2 pi e squared. Or you can just say this is the volume of a cylinder with height 2 and radius e. So the rotational volume, then, let's call it Vr, is this W minus 2 pi e squared. And here we have a minus pi e squared. So you get pi to the power times e to the power 4 minus 3 pi e to the power 3. And no, e to the power 2. E to the power 2. Which you can simplify a little bit. I don't think you will lose points if you don't do that. but it's pi times, you can factorize pi times e to the power 2. So e to the power 2 minus 3. Okay. So yeah, this is a little bit tricky because of this open area here. This equation you learned for the solid volume of rotation or revolution, it is only valid when you it doesn't take into account like a center hole like this. So yeah, this is a little bit of a difficult one. To see the function h and k are given here. Compute exactly the values of x for which x is kx. Okay, at least that's a clear thing they're asking. So we need to set them equal. Log 2x. And here we just combine them into kind of two logarithms on both sides. So we can say log x squared equals log of x minus 2, 2x plus 3. And then be sure, yeah, okay, this is correct. Now we can use that if this is true, this is actually equivalent with, this is also something that's in the syllabus, equivalent with x squared equals x minus 2. Just need to be a little bit careful that any solutions have to be in the domains of the functions. Okay, is this correct? All right, now it's just algebra. Combine all the like terms, so you get an x squared, and here you get a 2x squared. So I bring this to the left, I get negative x squared. And minus 4x plus 3x is minus x. So I get a plus x. And what about the constant term is minus 6. So I get a plus 6 is equal to 0. And just multiply by a minus sign, the x squared minus x minus 6 is 0. Can factorize. So factors of 6 are say minus, yeah, you can have you can combine a 2 and 3 to get a minus x. So you get x plus 2 times x minus 3 equals to 0. So x equals negative 2 or x equals 3. Then we just need to be sure that it's in the domains. So negative 2 is not in the domain of a logarithm. So the function is not defined there. So I eliminate this. 3 is okay here. 3 minus 2 is okay. Yeah, so the value of x is given here. Okay, question 3. there is a part of the graph of this function here. V is the region enclosed by this part of the graph and the x-axis. And we need to calculate the area, so we need to calculate the integral. But the first thing is, obviously at 0, the function is 0, but we need to figure out where it intersects here, the x-axis. So we need to find where is this function 0. That means that the sine of x minus sine of 1/2 x equals to 0. Or the sine of x equals the sine of 1/2 x. This kind of equation occurs a lot in these exams, so you have to be familiar with this. And what you use is that the sine, if the sine of A is the sine of B, you can say that A equals B, of course, plus 2 pi k, or because of the symmetry properties of the sine, or A is minus pi minus B plus 2 pi k. Okay, definitely remember this. For the cosine, it's just A would be plus or minus B plus 2 pi k. Okay, so x equals either 1/2 x plus 2k pi, or x equals pi minus 1/2 x plus 2k pi. The first equation will then give, bring 1/2 x to the left, so 1/2 x equals 2k pi, which then will have, which means x is 4k pi, which will have then solutions. If I look at this positive solutions to find this one, we have 0, 4 pi, 8 pi, etc. So let's look at the second. Then you get 3 over 2x, bringing x, this half minus half x to the left. It's pi plus 2k pi, which means x is 3 over 2 pi plus 4 over 3 k pi. And that has the solutions 3 over 2 pi. If k is 0, if k is 1, you get well, I don't even, I'm not even going to, wait, this is actually 2 over 3, of course. Anyway, here you get 6 over 3 pi and others, but we really want to know the first one. So it's 3 over 2 pi. Okay, so we found our upper boundary here. So we need to integrate from 0 to 2/3 times pi of that function. And the primitive of sine is a negative cosine. So here we get a plus, and with the chain rule, if we do it for sine 1/2 x, we pick up a factor 1/2 that we need to compensate for. So you get a factor 2. And I can double check it by actually taking the derivative again and show that it's equal to the function. And this whole thing between 2/3 of pi and 0. So you get minus the cosine of 2/3 pi minus the cosine 0. And then let's do it. Yeah, so you get plus 2 times the cosine of 1/3 pi, and then minus negative the cosine of 0 plus 2 times the cosine of 0. Okay, very easy to make mistake. Let's just double check everything. So the minus goes in 2/3, the 2 times the cosine of 1/3 pi. Now we substitute here. Okay. What is the cosine of 2/3 of pi? Just do your unit circle. Uh, which is not easy. So 2/3 of pi. So this is 1/2 pi. And then you go 1/3. So that is 1/2. And so this is negative 1/2 actually. So you get positive 1/2 here. And then 2 times the cosine 1/3, 1/3 of pi. Which is plus 1/2. So you get plus 1. And I just double check these things as well in your calculator. And here you get plus 1. It's from here. Plus 1, and here you get negative 2, 1. So in the end, you get 1/2. All right, next question, 3b. We have this interval and a function g given here. What are the x-coordinates of the intersection of g and the x-axis in a given interval? So the x-axis is y equals to 0. So we need to find for which axis in that interval the sine of x plus the cosine of 2x is 0. So let's try to, if you see something like this, just look at the formula that are given if all is well or in the back. Here, cosine 2t is 1 minus 2 times sine squared t. Let's see if that goes somewhere. So it means the sine of x plus 1 minus 2 times the sine squared of x is 0. And that looks like a quadratic equation in sine. So you get sine minus 2 times the sine squared of x plus the sine of x plus 1 is equal to 0. And that, let's see if we can factorize that. Well, let's first define u as the sine x, and you get minus 2u squared plus u plus 1 equals to 0. It makes it a little bit more clean. You don't need to do this, but in other thing, it's a little bit more convenient to just have a 1 in front of here. So this is u squared. And so I can divide by minus 2. Minus 1/2 u plus 1/2 equals to 0. And then see if we can factorize this. If not, probably it's actually the best to apply the square root formula to solve this. So like the x is 2a plus or minus the square root thing, but let's first see. Um, stop, go back, remove that last sentence. So start here. See if we can write this as something with 1 times a half. Look at this. Wait, this is actually, this should be a negative sign. So yeah, we can say u minus 1 times u plus 1/2 equals to 0. So we get our minus 1/2 here and minus u plus 1/2 u. So, and going back to what u is, that means that the sine of x has to be 1, or the sine of x has to be negative 1/2. So let's look at the first one. The sine of x is 1. And let's actually draw a unit circle. The sine is the projection on the y-axis. So when is that 1? Well, when x equals pi over 2. And that's all we have in this interval. So this gives x equals pi over 2. Now the sine of x is minus 1/2. Well, minus 1/2 is here in the unit circle. So we are here, and this is x is, so this is 1, this is 1 over 6. So this is pi, so this is pi plus 1 over 6 pi equals 7 over 6 pi. And this one is just x is pi plus 5 over 6 pi is 11 over 6 pi. You can also say that it's minus 1 over 6 pi, and then add 2 pi to it. Then you get the same. And yeah, these should be the 3 solutions then in this interval. So this one, this one, this one. Okay, question 3c. We have that function h of x given, and they tell us that it has 4 horizontal tangent lines. And we find the equation for each of these tangent lines. So we need to find the axis for which this derivative is 0. So the derivative of this function is using the product rule. We get cosine of x for the derivative of the sine times the cosine of 2x plus the sine of x times the derivative of this one here, which is minus 2 times the sine of 2x. So we get cosine x times cosine 2x minus 2 sine x sine of 2x. So let's just apply this formula for the double angle again. And go back to here. So the sine of 2x will be 2 sine x cosine x. And for the double angle of the cosine, we use the one we used in the previous exercise. So this is equal to cosine x times 1 minus 2 sine squared of x, and minus 2 sine x. What does it again? 2 times cosine x times sine x. This has to be equal to 0. You can see here we can factorize the cosine. So you get cosine x, and then you get say the 1 minus 2 sine squared x. Oh, and here you have another minus 2 times 2. Okay, let's minus 2 times 2, or minus 4 sine squared x, put on 0. So these are actually the same terms. Cosine x, 1 minus 6 times sine squared x, 0. And now we can just say that it means either the cosine of x is 0, or the sine squared of x is 1 over 6. And we have to figure out where this happens in this interval. So this one, let's say 1 and 2. So 1 means, oh wait, there's no interval actually. The cosine of x equals to 0. What are the y values? So cosine of x is 0 means x is see if I can put another unit circle. Oh, that's not a success. Let me see. So the cosine is 0 and the projection on the x-axis. So you're really looking at here. So means x is 1/2 pi plus 2k pi. Well, we can just say plus k pi because it happens here too. So it's just happens. Happens like this. And we need to figure out what because we need to find the exact line. So we need to figure out what is the function there. Well, if you multiply this by 2, you still get 0 all the time. See, if x is this, then 2x is pi plus 2k pi. And at that cosine, so the cosine of 2x, so you will, no, you will be at, I was wrong. Your cosine will be -1. For all values of k. So even if you're here, actually when you multiply by 2, you still have the cosine of 2x is 0. So then actually it doesn't matter what the sine x is. You can hx, h, hx for these functions are okay. So we get these two equations, a 1 and 2. Well, let's first look at the first. Cosine x equals to 0 means x equals 1/2 pi plus k times pi. That's that's basically uh, the x, the production on the x-axis has to be 0. So it happens here and uh, pi further, etc. And now what are the values for h here? Because we need to know the equation for the tangent line. We also want to know actually the y value of this line. And so what do we get, if this is the case, what do we get for cosine 2x and sine x? So we can just substitute this here. Well, the cosine of 2x in these points, you can write 2x is pi plus 2k pi. And at pi plus 2k pi, the cosine is always -1. And the sine, the sine of x is either 1 or -1. So the sine of, well, this particular axis is either plus or -1. So it means basically the h of x is either 1 or -1. And let's look at these others, that the sine squared of x is 1/6. And so sine, actually we probably should write this uh, as sine of x times 1 minus 2 times sine squared of x. Because we know exactly what the sine of x is. then we can just substitute it here. So this is yeah, basically okay. Actually I can keep it like this. So h of x is the square root of 1 over 6 times 1 minus 2 times 1 over 6. Okay, cut earlier. And the other possibility is, so because this means sine of x is plus or minus 1 over 6. That is just solving the equations, the a squared is something, and this is an even exponent, so you can have both plus, plus a negative square root. Oh, wait, square root, sorry, the square root. So, but the square is always 1 over 6. So this is actually, let me write as this the two solutions, summarize it like this. So you get plus or minus square root of 1 over 6 times, this is 1/3 times 2/3. Okay. So that means hx is plus or minus the square root of 6. And then you get the square root of 6 squared, of 6 times 2 over 3. And this is 2 divided by 18 is 1 over 9. So 1 over 9 times the square root of 6. So the lines are then, so we know the lines are horizontal. So the slope is 0. That means the lines are y equals, what was it again? Minus 1, or y equals to 1, or y equals to 1 over 9 square root of 6, or y equals minus 1 over 9 times the square root of 6. So we have these points A, minus 6, 1, and B, and line L is parallel to the lines through A and B, but it passes through the point on the positive x-axis, which has a distance 10 to point B. So let's try to draw that situation. Let's have a set of axes. and A is minus 6, 1, 1, 2, 3, 4, 5, 6, somewhere here, and B is 1, 8, 1, 2, 3, 4, 5, 6, 7, 8, roughly here. We just know that line L is parallel to the lines to these points. So some are going in this direction, but it passes through the point on the positive x-axis with distance 10 from point B. So we would need to find all the points that are 10 away from point B. So like a circle, we would need to let's see, can I make this transparent? Let me bring it down a little bit. So it's something like this. This is a circle of radius 10, and then we see where it crosses the x-axis in this point, but this is the negative x-axis, and this point. That means the line we're looking for is parallel to AB. So that line will be roughly something like this, parallel to AB and going through this point. So what we need to do, finding the slope of this line is easy. The slope, or actually they're asking for the vector representation. So we look for the direction vector. Will just be the vector OB minus OA. So the direction vector of the line is the vector OB minus OA. That's basically the vector here from going from A to B. So this is 1, 8 minus negative 6, 1. So 7, 7, 7. So it's actually corresponds with a slope of 1. Because you go 7 to the right and then 7 up. And as a direction factor, you can, this is actually proportional to 1, 1. So 1, 1 is also a valid direction factor. So the direction factor only tells you the direction. Actually, the length of it is not important. So let's actually take 1, 1 as the direction factor. And okay, so what's this point? So we need to find the intersection of this circle with radius 10 and center B with the positive x-axis. So let's call this point C. So point C, we need to solve for x minus 1 squared, and the y coordinate of this is 0. So you just have 0 minus 8. squared has to be 10 squared. That's the radius of the circle. So we get x squared minus 2x plus 1 plus 64 is 100. So x squared minus 2x plus 65 I subtract 100 from both sides. So minus 35 equals to 0. So that is, see if we can, 35 is, well, let's look at the factor 7 and 5. They cannot combine to 2. So you get x plus 5 times x minus 7 equals to 0. So x equals minus 5 or x equals 7. Well, minus 5 is on the negative x-axis, so we know that x has to be 7. And of course, y is 0, so c is 7, 0. So that is basically a point on the line, so that kind of can determine a position factor of the line representation. So L is then given by, so this is the position factor, by 7, 0 plus lambda 1, 1. All right, 4b. There's the circle C1 with center minus 1, 3. That passes through A and B. B is also on the circle. Oh, they want to show that this circle C1 also has point B on it. So I'm not sure if let's see, minus 1, 3, it's roughly here. So I can again try to add a circle. And maybe, can I color it different? I don't know how to do that. But it would be roughly this circle. C1. Yeah, it looks, well, I didn't center it perfectly, but it looks like that B is indeed on the circle. Well, how do we actually prove that? Or was that 4C? Oh no, 4B, 4B. Well, we know that A is on the circle, and we know the center. So we just need to verify that the distance from B to that point, that center, is equal to the distance of A. Okay, that's actually pretty easy. So what's the distance of A to P? Well, that's it's -6 minus -1 squared plus 1 minus 3 squared, and then the square root of this whole thing. And this is a -6. This is 7 squared. Ah, no, -6 plus 1 is 5 squared plus 2 squared. The square root, that's the square root of 29. So let's check the distance P, and I get 1 minus, again, -1 squared plus 8 minus 3 squared square root. So that is 2 squared plus 5 squared, which is really good because it's also the square root of 29. B is on circle 1. Question C. There are points D on circle C1 such that the triangle ABD is a right angled triangle. Compute exactly the coordinates of these points. So roughly here is a point B, and then there's a point C here, and then the center of the circle. Sorry for wasting everybody's time. So there are points D that so say A is here, E is here. So there's a point D for which the ABD is a right angled triangle. Now, the question, so D is somewhere on the circle. The question would be where that right angle is. They don't specify that at all. But what we first can check is whether or not, yeah, so one thing that is usually the case when they talk about right angle triangles and circles is that if you have a circle and a diameter, then the opposite angle here, the diameter is 90 degrees. That's the Taylor's theory. So let's first check if this point is AB is actually the diameter of the circle. And that would be the case if this center point P here is, so let's say the vector OP is equal to 1/2 A plus B. Basically, if that's in the center of these, I probably should put an O here. Let me just drop the origin since all the factors are with respect to that. So whether or not that's the case, well, 1/2 A plus B is 1/2 minus 6/1 plus 8/1 is 2.5, 4.5. So the coordinates of this point are actually not equal to the center, which is -1, 3. So yeah, so the center is somewhere here, different x and y, a little bit to the, and this should be negative sign. So the center of these points A and B is somewhere above and to the left of the center. So we know, let's already write this short. And that means that either, so if you have point D, that means that either BD has to be going through the center, or AD has to go through the center. So that means that D is right here. That's option 1, and do option 2 in other color is that D is right here. So in this case, this is a right angle, and in the other case, this is a right angle. Okay, so yeah, that's it. Now, if we know that BD or AD has to be a diameter, we can actually immediately calculate D, because if let's look at this case first. D has to be, the vector has to be B plus 2 times the vector going from P to B. I would say PB, because that will make uh, of 2 times 2. Because that will make the center of the circle right in the middle of the 2. So this is D. Wait. So I should say, let me give a bit more space. So again, point B is known. We know the coordinates of this and we know the coordinates of P. So we calculate D by saying D is B plus 2 times the vector going from B to P. So this is 1 and this is another one. So now we just need to figure out, so B we know. What is B? P? Well, that's the vector P, which is minus 1, 3, minus B, minus 1, 8. So that's the vector minus 2, minus 5. Right? It's the vector, you can see it's going in this direction, minus 2, minus 5. So that makes sense. So then we find B equals 1, 8 plus this vector is this is a negative sign, minus 1, 3. So that should be one option for point D. This doesn't make sense. Minus 1, 3. Ah, okay, it's getting late in the exam. I should have multiplied this by a 2 here. Actually, I was getting minus 1, 3, which is the center, which of course should be the case. Okay, so plus 2 times this. So it's 1, 8 minus 4 minus 10. So it's minus 3 minus 2. So this is, say case 1. Case 1 is that BD is the diameter. Now case 2, in that case D is A and then plus 2 times the vector from A to P. That is minus 6, 1 plus 2 times. Okay, I need to also calculate AP. So AP is minus 6, 1 sorry, is -1 3 minus -6 1 is 5. It's a factor 5 2. So means let me see if that makes sense. So from A to P, roughly makes sense. You go 5 to the right and 2 up. So you get in 2 times that factor. You get in D here. So that is -6 plus 10 is 4. And then here we end up in 5. Okay, so now we have found our D. So D is, what does it again? -2 -5. No, still always easy to make mistakes. -3 -2 or 4 5. A circle C2, center M, also through A and B. The area of the triangle ABM is 14. Compute exactly the area of circle C2. Okay, let's insert a circle here and say A is roughly here and B here. From the previous questions, and there's a center somewhere, M, and these can be said to form a triangle. And for the base, we can select any of the sides. Uh, we can, for example, it probably doesn't matter which side you take, but let's take AB here as the base. And the base is the segment AB. And that's something we know we can calculate. The distance from A to B is 1 minus -6 squared plus 8 minus 1 squared square root. So that is 7 squared plus 7 squared. That is 49 times 2, the square root of 96. No, 49. Oops. It's so easy to make mistakes. Square root of 89. Now, 98. So 98, we just simplify is 2. Of course, we have a 49 back. Oh, that's just divisible by 7, 7. So 98 is 2 times 7 squared. So this is equal to 7 times the square root of 2. So now we know the base, and we also know the area of the triangle is 14. So let me erase this. Area equals 14. So 1/2 times this 7 square root of 2 times the height has to be 14. This means then that h equals 28 divided by 7. Divided by 7 is square root of 2. Oh, this is 4 divided by square root of 2 is multiplied by square root of 2 divided by square root of 2 is 4 times the square root of 2. So that's h. No, I get I need to divide by 2 here. So, oops, it is 2 times square root of 2. So again, I divide numerator and denominator by the square root of 2. So I get 2 here in the denominator, so 4 divided by 2 is 2. So that is our h. Now I know h, and I also know the length here. This is half the base. So I can use Pythagoras to say that r squared has to be the height squared, so 2 square root of 2 squared plus, and yeah, plus 7 over 2 square root of 2 squared. Well, this is 4 times 2 is 8 plus 49 over 4 times 2, which is 8 plus 49 divided by 2 is 24 and a half. Oops, no. It's 8 plus 24 and a half. And let's keep it in the as the r squared. So this is 32 and a half as r squared, since we're actually asking the area of the circle. So the area is circle is pi r squared. So I just need to multiply this thing by pi. So I get pi times 32 and a half is 32 and a half pi. And that's the final question. Tough exam. Tough exam.